What makes the network reliable? Well, there's 4 things that they're going to find in the Cisco material. But obviously, if you start up your connection and the person on the other end can't hear you, if you were doing a voice communication session or making a phone call, then it's not very reliable. If you were trying to do video, but I couldn't identify who you were on the other end, then the network's not very reliable. What about up or down time? Let's say, for example, that you guys went to Chili's to get some margaritas if you were over the age of 21 or 21, and they couldn't take credit cards. Most everybody would probably be sunk, right? Because how many people are carrying cash these days? Few people. So Chili's is going to have some form of fault tolerance to combat that. So we had multiple internet connections or multiple ways to process the cards to keep that from being a problem. Quality of service is one of the things that makes up reliable networks. We put that in play. It's also referred to as traffic shaping, if you wanted to look up the term traffic shaping. And we build our networks with enterprise gear, and we add these things like quality of service and fault tolerance in to make sure that our network is reliable and online all the time. Another thing that makes up a reliable network is scalability. So we need our network to be able to grow, expand, change with us. If we put something in today that cost $100,000, then we don't have to redo that next year just because we want to add another classroom or another part to our business. So we need to be able to grow what we have. We don't want to have to rip it all out and change and start over again. And obviously security is a big part of making something reliable, because if USM leaked all of the data of every student in the university out into the internet, our network's not very secure, and that would make us look really bad, and it would probably cost us lots of money. So security is becoming a more and more important role inside of our networks today. All 4 of these things make up a reliable network. So again, fault tolerance is put simply, is a way for us to get things from point A to point B without ever not being able to do that. So you can see here they've got arrows pointing at multiple connections, so that if a piece of equipment failed, like a router, we still have another path to the remote destination network. We do this by having 2 firewalls, 2 routers, 2 internet connections, 2 different providers going 2 different directions. We have multiple switches. We have battery backups. We have generators. So we have all these things that adds up to lots of dollars that keep things online 100% of the time. So we don't want a lightning storm to occur and take power out, and then people to not be able to use their phones. And again, the ways that we keep those things online is through battery backups and generators. So redundant. Scalability, simply put, is just making sure when we design our network that adding another leg, so you can see in our example, they've got a darker set of lines to a new LAN or an additional user. So maybe a new classroom went online or another building. Something happened. We bought another location. We're standing up a new store. Whatever that is right there, it didn't cost them a whole lot because the router already had the capability to add a new connection in and provide a new LAN for us. So quickly and easily to support new users, applications, new locations. We've designed it out that way. It's scalable. Again, quality service is a lot more technical than what they've got in the slide, but basically our equipment, our enterprise routers, or appliances have the ability to do something called traffic shaping, which means that if my internet provider bandwidth is reduced down, or I start having latency issues, and I know you guys that do games would love this, so we could actually tell the appliance that, hey, the bandwidth is dumbed down. So we want to tell everybody that's got a phone, everybody that's got a PC that's doing email, everybody that's trying to get onto a website, that they're going to wait in line. And then we can let all the games go out and use up the internet bandwidth until it became available again, and then we would let the phones and the other day-to-day things go back online. Obviously, we're not going to do that. You know, that would be kind of silly, right? Let the gamers have all the internet and then and let the day-to-day business die. But in the real world, we would put in traffic shaping that says, hey, if we're starting to have latency issues or jitter or something slowing down the internet, phones are going to take precedence. Video conferences are going to take precedence. And so while they're consuming the bandwidth, the other things like the email and the web surfing is going to get put into what we call queues. So they're basically going to line up, and we're going to let that happen as it becomes available. Network security used to be antivirus software that was running on endpoints. It's not enough. If you do some research, you'll find out that antivirus, if you're running any kind of antivirus products, those things are signature based. They're about 50% effective, and the reason being is because there's a new threat probably released every minute. So how do we fix those problems? Well, we do a lot of data capturing. So we're watching the data to make sure that somebody's not changing it or they're not stealing it. We're putting layers upon layers of security in place. So if you're smart, you have content filtering, which means that machines on my network are not allowed to go to Russia. There's probably not anything over here at USM that I need to go to Russia. So we can filter content, we can filter by location where things are going. And then I have something in addition to antivirus that's being used for tracking threats. So they have new real-time applications where we're actually monitoring data and changes to systems so that we can identify known threats. These things have been referred to called all different kinds of things, but intrusion detection or intrusion signature analysis is kind of what they are. And we're using AI even to identify threats within minutes instead of months or years.